So now that we are getting used to Equation Editor, those of you just joining this video, we're looking at a weather forecast, a screenshot from a phone. So far, we have used a ratio table to organize. We converted AM PM times to 24-hour clock times to help with arithmetic we might need to do later. Degrees are in Fahrenheit. The freezing temperature of water in Fahrenheit is 32 degrees. The time in a 24-hour clock starts at 0 hours. What was the temperature at midnight? It was not 0 degrees today. So in this situation, 0 for hours does not correlate to 0 for temperature. So when we think of this, it can help us try to make sense of the rates and ratios. We need to always return to the fact that 0 degrees temperature does not mean an absence of heat. We also need to think about what is the 0 of our 24-hour clock. That would be midnight. And what is the 0? What is the absence of hours in a day? It would be like that first moment of the day. What's the absence of heat? Fahrenheit doesn't really measure that. It's a really negative number. Okay, that was a quick preview. Now we're focused on number 2. What is the ratio of temperature to time of day for 600 hours and 900 hours? So separately, what are the ratios separately of temperature to time? Compare the ratios. Are they equivalent? So at 600 hours, 6 hours into the day, so this also means like 6 hours into the day, we can expect the air temperature to be about 30 degrees. Now, this does not mean that the temperature rose 30 degrees in 6 hours. We don't know what the temperature was at midnight from this information. Okay, so just keep that in mind. At 900 hours. Oh, and let's go ahead and insert some other formats of ratios here. So we can use a fraction format. Remember, this is not actually a fraction. It is a fraction format because we're not taking a part out of the whole. In this case, we need to remember that the numerator is representing a measurement different from the denominator. So 6 hours, so 6 hours into the day over 30 degrees. Okay, so I'm going to write o'clock, and I'm going to write, I wonder if I can put this in there. That would be so cool. Perfect. And then instead of 6 o'clock, because that kind of looks funny, I'm going to write 600 hours. Because in mathematics, we want to be clear and try to limit a bunch of distracting notes and stuff. When you're getting used to it, every note might seem distracting, but eventually you'll get the hang of it. Another way we can write this is using the words for every or each or to. And in the sentence I wrote below, it doesn't have any of that language. At 6 o'clock, 6 hours into the day, we can expect the air temperature to be about 30 degrees Fahrenheit. And you think of that and you're like, wait a second, is that a ratio? I'm not, like, where's the for every, where's the to, where's the each? And it's kind of hidden. So mathematics also is giving yourself a little credit to make sense of it the way you make sense of it, and be okay with making sense of something a little bit differently than your neighbor. That's actually beautiful. Using the language of for every, we could say it this way. Ooh, this is tough because we can't really say for every hour, we can't really say for every 6 hours the temperature rises 30 degrees, increases or rises, because the 30-degree Fahrenheit is a positive number, which implies warming, like getting warmer, or warmth, right? Even though 30 degrees is cold, it's saying like for every 6 hours, the temperature but it's not a rate. So I'm deleting it. For every doesn't make sense here because this is not a rate, it's a ratio, which is kind of beautiful. I love that we're having this conversation. So since this is a ratio, it's just comparing to associating two quantities. So this ratio associates the time of day at 6 a.m. to the temperature of 30 degrees. It's not a rate. For every doesn't really make sense here. It's just telling us a stagnant moment in time. So let's repeat this for 9 o'clock, and then we will look at a rate. So this is a ratio. Okay. I'm not entirely sure I have to. There we go. Okay. Just like formatting. Hopefully it helps read. So we have some ratios. These are like stagnant, okay? Stagnant moments in time, not looking at change over time. We have the 600 hours. Now we need to look at 900 hours. So at 9 o'clock, the temperature is 34 degrees Fahrenheit. 9 o'clock, 34 degrees Fahrenheit. At 9 o'clock, 9 hours into the day, we can expect the air temperature to be about 34 degrees Fahrenheit. The ratio associates the time of day at 9 a.m. to the temperature of 34 degrees, to the predicted temperature, or anticipated temperature of 34 degrees. We have two stagnant moments in time. The temperature at 6 a.m., the temperature at 9 a.m. Let us now form a rate of change. Okay. And then hopefully a unit rate. Rate. This is 11 font, so I want them to be the same. Okay. And indent. So the rate. Now we can go back to our new equation. So we're thinking we're trying to get to a rate because we've already recognized that the ratio at these stagnant moments in time don't give us information about what's coming before or after. It's just this moment in time, right? The next moment it could increase 400 degrees. It wouldn't, but it could. And we have from moments in time, we have no ability to kind of guess what's in between. When we take two moments in time, then we can start looking about what's in between. So it's like locations and then how do they connect? So the rate is the connection between ratios almost. Okay. I left equal signs here because I want to turn these ratios into a unit rate. And show that it doesn't really make sense. So if every 6 hours, and wait a second, I think I did it backwards. It says compare temperature to time of day. So I did it backwards. Let's fix it. So it's 0600 hours to 30 degrees Fahrenheit. And we have the degrees Fahrenheit symbol now. I can get rid of this messy stuff. There we go. And I need to flip these. So I will make a new fraction and put 30 degrees Fahrenheit in the numerator. Now, I didn't change this ratio at all. It's how the order matters because the quantities are different. So you just need to be clear to your reader, to your future self. Sometimes we just write notes to our future self. Sometimes you write notes to a teacher, a friend, whatever. Your audience just needs to know what numbers are going with which quantities. So writing it this way, it helps us think about temperature per hour. A lot of times rates are formed per hour, per the time, how much time has passed and what's going on while that time passed. passes. So if we took this as a fraction, it would turn into, 30 divided by 6. As a fraction. But what? 30 degrees over 6 hours, which is equivalent to, 30 divided by 6 is 5. So 5 divided by 1, or 5 to 1, right? Division, comparison, association. And then 5 to 1 what? So it's 5 degrees every hour. That doesn't make sense. 5 degrees per 1 hour does not make sense here because the temperature did not start at 0 degrees at 0 hours. Okay? So let me turn these red because this is a misinterpretation. We always have to ask ourselves, as the mathematician, as the human, does this make sense? You're not going to feel confident if you're just doing things because you think you're following the rules or you just doing what your neighbor's doing. You want to be an agent in your choices when you're doing mathematics. Okay, so here I'm an agent. I'm saying this isn't working. Okay, it doesn't make sense because of what I know about mathematics. This does not make sense. Okay, the same thing happens here if we switch everything around, which it should. And the nice thing is I can just grab it all and paste it. Okay, so we're switching 30 degrees to the 9 o'clock hour at 34 degrees, and we're rearranging everything so that it's in the right order according to the question, which is comparing temperature to hours, not hours to temperature. So here we have 34 degrees, 900 hours, 34 divided by 9. It's a beautiful opportunity to start making sense of division. And the way I do division, I don't rely on long division often. Here, what I would do is I'm going to think about, 9 repeated. So 9 plus 9 plus 9. I am at 3 nines. Okay, so that's equal to 3 times 9. And a lot of you still rely on the multiplication symbol, so I will include it, but eventually it'll turn into a multiplication dot or nothing at all. Remember, mathematicians like to simplify what we have to write. So here is me trying to make sense of this division problem, 34 divided by 9. Okay, so when I'm thinking about 34 divided by 9, again, I'll write it out because I know that we all see things differently. We see how many times does 9 repeatedly fit into 34. So it's 3 times 9 is 27, so I need more. I'm going to add another one, plus 9. This makes me have 4 nines, which takes me up to 36, and I've gone too far. Okay, so it's going to be between 3 nines and 4 nines because 3 nines wasn't enough. It took me to 27, and 4 nines was too much. It took me to 36. So I need only 3 nines. Takes me to 27. But I need more because I need to get to 34. So to get to 34 from 27, I need 28, 29, 30, 31, 32, 33, 34. I need 7 more. So plus 7. But where am I getting those 7s from? I'm getting them from 9s. Where am I getting those 7 units? I'm taking it from a chunk of 9. The units come in blocks of 9 because that's my divisor. So I'm not just, my answer needs to reflect what I'm dividing by. You need to give your reader or your future self a note as to what is the divisor. when it's not an even division or a factor where there's nothing remaining, when your quotient, your answer to your division problem, is not a whole number, then you think here, okay, so I have 3 9s and they fit into, I guess I can't change the color, 34 3 times, right? The 3 9s fit in together with 3 makes 27. There's a remainder of 7. So you all are kind of used to this R7. But instead of R7, we can say it's just 7, remainder 7, but 7 out of what? It was 7 ninths. So then we can say we multiplied 9 by itself 3 times to get 27, but to get to 34, I need 7 more. 7 what? 7 ninths. Okay, so what I need to write here is that 34 divided by 9 is the same thing as 27 divided by 9 plus 7 divided by 9. Because if you see 27 plus 7 makes 34. Okay, well, I can simplify 27 ninths to 3, and I have 7 ninths left over. But I don't need to put that plus sign. That's why we have mixed numbers. Why do we have mixed numbers? Because mathematicians don't like to write an addition sign if we don't have to. And then 7 ninths is going to be a repeating decimal because thirds, sixths, and ninths don't fit into 100 evenly. 3, 6, and 9 are not factors of 100. So what I can do is just go to, our good old friend Google, figure out what 7 ninths is. We can work out how to do this by hand. It's a process. You can take a variety of ways, but for now, when we have the tools, I like to use tools strategically when they're appropriate. We have 7 repeated. So we could also say that the answer is 3.78 about, or we could give it the little hat. Some of you like to use the hat. 7, okay, and then if you want to use the approximately equal to symbol, it'd be, 3.8. Okay. All of that just to say it doesn't make sense because we're not increasing 3 and 8 tenths of a degree per hour. That's not what this is saying because we didn't start at 0, 0. Okay, so all of that just to get to rates. I'm going to stop this video, and then the next video will be about rates.